Alright, so this is another form or another way that I'm going to be documenting myself, which is by doing Leetcode. So I will be doing the blind 75 and then moving on to the blind 150. This is more so just a documentary for me to learn, put myself or make myself accountable. Yeah, I mean, during this whole Leetcode process, I believe I would follow the structure of trying to solve it myself. If I can't solve it myself, ask AI in a way where I'm not asking it for the answer, but in a way where I ask it to question me, to nudge me closer to the answer without giving it away. And then watching some Leetcode. So again, this is just an in-depth study. I also want to use this opportunity to learn more about C++20, some optimizations I can do, whether it's small, such as using .reserve to reduce cache misses within an unordered map and so on. So yeah, I guess I'll just start this. So I'm going to be working on this GitHub repo, which is called Leetcode. I had done some projects, or not projects, but problems within this. I deleted them all. It's been quite some time since I've done the problems, so I will be repeating them. I believe if I go to my blind 75, it's already pretty much filled in. I only got up to here, got a long way to go, but I will be restarting. I'll also be doing some miscellaneous Leetcode problems, but enough yapping. Let me just begin. Why is there folders being shown? I thought I deleted them. Yeah. Oh. Leave. Sliding window here. Alright, let's do the first problem, which is hashing contains duplicate. Yeah, right. I will be writing notes as well. Hashing. Contains duplicate. Do this. Alright. Okay, I don't think I have a docket ignored here. What is it? Okay, hopefully that ignores all of the all the executables that build. Yeah, alright, so let's start with this one then. Let me just build out the template. I already made a template here though. Yeah. Contains duplicate, yeah. Alright, I'm gonna take this. Alright. Use rescue. Those are recording. Alright. So let's do this one. Alright, so contains duplicate. Given an integer array, nums, return true if any value appears more than once in the array. Otherwise, return false. So we just want to determine if a number appears more than once and so on. Yeah, alright, so I think this is how I'm gonna set it up. I will think about a brute force solution first. So let me write notes. Alright, so what do we want again? We want to determine if an array contains more than one number. Or not more than one number, but contains a duplicate of a specific number. So all the elements in the array should be unique. So easiest thing to do is have a double for loop, right? So what was it? Was it like this? So we can kind of just think of it like, for each of the numbers, here, let's draw it out. So, have 1, 2, 3, 3, right? 1, 2, 3, 3. 1, 2, 3, 3. We'd essentially take a look at this number and then scan the entire array. Then take a look at this number, scan the entire array. Take a look at this number and scan the entire array. And whenever we're scanning the entire arrays, at any point in this time, if there does contain a duplicate, then all we're just going to do is return false. Else, we would return true, right? And because of this, we are basically traversing it of n squared times via the Gauss formula. But essentially, it looks something like this. For I all the way to the size of the vector, right? For j all the way to the size of the vector, we just would say if nomad I is equal to the nomad j, then return true, else return false. Again, like we noted earlier, with it, caution, this runtime would be O of n squared. I guess space complexity as well would be O of 1, because we're not really allocating any extra space for this problem. We're just using the space that was already given to us, which is the vector that was passed in. Alright. Sorry, this should be true. And this is actually false. Alright. Now, the more optimal approach would be using some sort of map or some sort of data structure to keep track of whether a duplicate exists, right? So I guess going back to the 1, 2, 3, 3, 1, we could keep track of a map where the key is the actual num at I, and the value is going to be the frequency. So in this case, what would that look like? So we would store 1 because of this right here, the frequency would be 1. Store 2, frequency would be 1. Store 3, frequency would be 2. And when a frequency crosses 1, then we would return true, else false. And the way we do that is through this pseudocode. So unordered frequency approach. What would that look like? So we would initialize our unordered map, and then for I all the way to n, we would say something like, let's just call our map m. We would say m at I plus plus if m at I is greater than 1, return true, else we would just return false. Right. Another similar approach would just be using an unordered set, because I guess you don't really need the value pair for this problem. We just need to determine if something was already inserted. So instead of using map, we could say something like set, and then we could say something like s.insert I, check if s is already inserted, if I is already inserted, if yes, return true, else we would do this right there. Alright, this is what? And I think I would use the unordered set approach, right? Just for the sake of it, runtime would be O of n. We're looping through each element exactly 1 time. Our our space complexity will also be O of n, because we're using an external data structure to store elements and add scales appropriately or respectively to the parameter we're given. So let's do that approach. Constant n is equal to size. What does this actually return? Is it integer or is it size t? What is size type? So in this case, I would just use AI to learn. Where is it? Alright. C++, I'm looking at the definition of vector.size and see this. How can you read this? Is it, what exactly is a size type? Does that return int or size t? Okay, so I guess this part right here is saying this is the number of elements and this is calculated by the difference. Because that makes sense, right? Because let's say theoretically we had an iterator or a pointer, one starting at the finish, one starting at the end, and the number of elements is simply the difference in between. Assuming that the iterator at the finish is one more than the actual last element. Okay, so that makes sense. So size is equal to finish minus start. What is size type? Size type is just a type alias defined inside. Oh, what the hell? Is it really? where would that type alias be? It's 1,000 lines. There's no way I'm checking through that. Maybe if using size type, using size. No. Alright, it's whatever. Alright, so it's an alias, so it actually returns size t. Okay. It returns, which is almost size t. Alright, if it returns size t, then I'm assuming it's also fine to say something like constant n nums.size, which just typecasts size t into an int. It works, but it's not something you should rely on. Return size t, usually 32-bit signed. Okay, yes, so integer is signed, size t is unsigned, right? Which makes sense because indexes can't go to a negative. Ah, okay. Alright, so is size t good practice to use in C++? Vectors. Okay, this is a fair point. It's really uncommon. Okay, so I guess using size t is helpful. Then again, it's not really needed, given that your vector should never cross like 2 billion, unless you're doing something wrong, I guess. But in that case, good C++ semantics says to use size t, so we'll be using size t. Alright, then our unnumbered set of integers. Then we would loop over, right? So loop over elements and nums, and then insert into S, or check if it exists, else insert. Right, so nums. Okay. I believe the insert returns. Let's check the C++ reference. Alright, so I believe the insert returns 2 variables actually, or a pair. So, what would that be? S.insert CPP reference. This returns the iterator and whatever this is. Let's do set.insert. This right here. So since C++ 23, .insert returns a pair, which is an iterator that points to it, and then a boolean, I'm assuming. Okay, a boolean that based on this right here. Where is it? I just read it. Okay, the boolean returns true if the assertion actually happened, false if it didn't. So false if something already exists, true if something doesn't exist. So I guess in here we can say something like IT bool, or maybe something like inserted, right? And then this would be something called s.insert num. Now, okay, this is called structured binding. That's what it was. Can't say const. What is the syntax for it? Structured binding in C++. Oh, is it auto? This auto makes sense. Okay. If inserted, if it did not insert, return true. Return false. And I think semantics says to put an underscore because we don't need the iterator, right? Yeah, that should pretty much be it for this one. So just one more time, get the size of the vector, have the unknown set, and iterate through all the numbers in the element or in the vector, try inserting it. If it's not inserted, return true, there is a duplicate, else return false. I think something else we could do here is say s.reserve. Okay, from my understanding, we should be using .reserve. When was .reserve introduced? When was .reserve introduced? C+ was in 98. Oh, okay, I guess it was introduced a long time ago, meaning 1998. Alright, so my understanding is that we should be using .reserve because it allocates space. Now, this allocates space ahead of time. Without default initializing. And I guess this is helpful because let's say nums was, what's a constraint we're given, right? What could nums possibly be? What's the size? I guess it doesn't give us constraints, but let's say nums was like 2 billion, right? In the case of 2 billion nums, an unordered set, I'm assuming acts like an unordered hash map. So if we were to write this out, it'll be something like this, right? We were to initialize the set, right? And let's say it starts off with a default size of 1, 2, 3, 4, 5, right? Without using .reserve, we would get this default size. And whenever we enter something, right, at some point we would hit our load factor, which is just the number of elements divided by the capacity and determining, based on whatever the load factor is, it could call for resize. And that resize could cause extra overhead. And that extra overhead will be copying every element into this new array, right, or dynamic array, and then rehashing everything and putting it into there, right? But with .reserve, instead of giving us this default, whatever that is, right, with .reserve, instead of giving us that default size, that would help prevent these resizes from happening. So I guess that's another reason why to use .reserve. Yeah, so let's just see if that works. Run. Submit. Okay. How can someone make this faster? What's another method then? Well, what could make my program slow? Is it this unordered set? I don't believe there's a shorter runtime for it, so I do think OFN is the right runtime. What is there? Could be the reason. Oh yes, yeah. Oh wait, that's interesting. Okay, so another solution looks like. Bro, I keep. Give me 1 second. tmux ls tmux kill session line 75 tmux kill session line 75. Okay, it's very interesting. So based on that code, they're saying that we can do the sort method, right? And sorting it, right, puts all the elements in ascending order. And if we were to sort them, then hypothetically, if there were duplicates, then numbers would be, or duplicated numbers would be placed together. So all I have to do is just loop through the array and find which one is next to each other, right? So it looks something like this, right? So sort vector, right? Whatever that syntax could look like in C++. And then if I nums at I plus 1 and return true. And that's pretty much all that is. My question is, though, is that the runtime for this one is runtime would be O of n log n, right? Because I believe most sorting algorithms are using quicksort, and you can't do a sorting algorithm that has a lower runtime than n log n. I believe it's just theoretically not possible. But this runtime is O of n, so how does doing this make it run faster? Let's see. Right, if we were to do it that way, if we were to do it that way, expected 4. Size t is equal to 0. I was less than n plus plus n. If this actually run faster? No, I mean, this will get 2 milliseconds, but his does get that, so I don't know. Yeah, I guess another solution to this one would be is something like count frequencies and store into array, right? Or initialize frequency array, and then for in just decrement. Actually, yeah, because I guess my idea was if we have 1, 2, 3, 3, just keep an array, right? At index 1 would increment 1, right? And this array would be of size 3 because that's the maximum number. But I guess that doesn't really work because we would have to loop over to find the maximum and then allocate it. And then even then, that's wasting space because if we had 1 to 10, then we'd have a vector of size 10 with, let's say, what is it, like 7 unused elements, which is just a lot of overhead. So I think this is the right idea. Oops. Yeah. So at least so. Alright. So we're gonna say that is done. Is that is. Contains duplicate. Alright, let's do valid anagram. Alright, I need K. Next question is valid anagram. CVP. Paste this. Alright, so given two strings S and T, return true if the two strings are anagrams of each other, otherwise return false. So an anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. Okay, so I've done this problem before, and I think this is kind of similar to, actually not similar, but all you're really doing is just trying to find out if the frequency of each character matches up with the other character, right? So if this string has R appearing twice, then R should also appear twice here, and the same for each one. So I don't think I need to go to a drawing board for this one. So the brute force solution is going to be so say we had strings car, right? Yeah, let's actually go to drawing. Alright. So if we had strings A, B, B as our S, right, and then our T is A, B, these should be valid anagrams because the frequencies of each character matches up. So the way we'd possibly be doing it is, it's the brute force solution. I think brute force solution would be to brute force other than using an unordered map. Honestly, one of the solutions could just be sorting the strings, right? And if we were to sort these strings, it would be A, B, 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 A, B, 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 and they'd be equal to each other, and then we just check if they're equal to each other. That runtime is going to be O of n log n. So what is another brute force solution? I guess another way to think about a brute force solution is for each character here, try and map it onto here, right? If we were to map it onto here, then we know that this place is taken, right? Then same thing with here, map it onto here, this place is taken, and so on. This would be O of n squared, or O of m times n, m being the length of this string and n being the length of this string. And because we're looking at each character here, that would be O of m, and for each of these characters, we're looking at all these characters here, which would be O of n. So by marking it as a placeholder, we can just find some sort of way to denote it as some sort of placeholder, maybe by using a pound. And at the end, t should be all pounds, right? And if it's all pounds and there's no alphanumeric or just no alphabets or no alphabetical characters in this string, then we know that this is a palindrome. So I guess brute force would be for each char in S, each char in T, right? If, okay, C, let's say C2. If C2 is equal to pound, right, then we just continue, else C2 is going to be set to a pound. And then at the end, we would say something like, for each character, so for each C in T, C does not equal to pound, return false, right, and then return true at the end. Also, another guard we can have, just as a basic one, we can put it under note. Have an early guard to check if the lengths are anagrams would always have equal lengths, given that their character are equivalent. So we can enforce our early guard there. Okay, now continue on with this one. We can say something like caution. Can I spell caution? Okay. Runtime of this would be O of m times n, I believe, given that m is the length of s, string s, and n is the length of string t. And space complexity would be O of 1. We're not introducing any external data structures, and so we're just using the strings that are given to us. So space complexity is O of 1. Alright. Let's think of another one. Alright. Another solution could just be keeping a frequency map, right? So back to what I was saying earlier, if we were to have, let's say, A, B, B, T is equal to EA, BA, right? Then if we had a map for S, right, S's map would look like S would map onto this. A has two frequencies, B has two frequencies. Here, T would have two frequencies for B, A would have two frequencies for T as well. So essentially we're constructing the hash maps, the frequency maps for each string, and then at the end, if s is equal to t, then we return true. I think that is the canonical solution for it. So second approach would be to use a frequency map, right? And the pseudocode for that would look something like this. C and S, right? M at C is going to be incremented, and then alright, and then just maybe here the map for S, and then the map for T, and just return ms is equal to mt. This operation right here should just be, it's an operator overload function provided by the standard library, and what that does is that it iterates through all the unordered, or all the elements under the unordered maps. Something similar to what this does, right? So const key val, and your whatever your map is called, right? And then I guess it also just iterates through them both twice and compares that for each of the keys they have the same values, and all the keys that exist should map all the keys that exist in another map. So yeah, let me code this one out. If we were to do it this way, then we can say something like, and we can have that orderly guard where it's const. Ooh. Okay. S length. Actually, no, I can say if s dot length. What does this return? It's a size t as well. Okay. Is equal to t dot length. And return false. Unordered map, or map to a triangle integer. S map. And then same thing, but for the t map. Char C and S, we would say S map at C, and then plus plus it. And then return S map is equal to T map. Yeah, so here build the unordered map. Anagram if maps are identical. Okay, so this is an operator overload function. So whatever this does, it looks like it's basically just saying that is this a function as well? Okay, here's the actual implementation. The size is not equal to the other size, return false. Of course, the sizes have to be the same in order to match. So start looping. I believe this is what that's saying. So many types going on here. Okay, so we have this hash map and the other hash map, right? So we're looping through our hash map. Well, this permutation. this so this spacing. Okay, well, this should be comparing each key to every other key, and then for all the equal keys, it should be comparing the values. So that's what I'm gonna go with. Should pretty much be it. Let's go back to here, submit this one, run, and submit. Okay, nice. Another way we can also think about it is by using, because what's a constraint on here? All lowercase English letters. So if we want to optimize space, we can avoid using unordered maps, right? So we can use a frequency array. It's gonna be similar approach to unordered map. Use arrays with fixed size of 26, and we can use arrays with fixed size of 26 because we know that SNT will only consist of lowercase English letters, and so that could save us space. So if we were to do that, okay, we can keep that guard there, but here is what we do instead. Alright, so we'd have an array, right? And here, if we had our S to be A, B, C, and T to be C, B, A, right? Then our map will only consist of the size of either one of those, right? Let's say we chose S. Doesn't really matter here because they're the same size. And then this index 0, 1, 2 would map onto index A, right? Again, we would always we would not create the size of the array based on the size of either S or T, but we will always make it to a size of 26, 3, 4, 5, 6, and so on, right? And this is still O of 1 space, or more specifically O of 26 space, because our array doesn't scale to the size of the input that we're given. It's always a fixed length of 26. So space complexity is still O of 1. Yeah, I guess we're just avoiding the overhead of using an unordered map that allocates more space than needed. But essentially, index 0 will map onto B, index 1 will map onto, or index 0 will map onto A, index 1 will map onto B, and the last index would map onto Z, right? This is 25. The way we do this is iterate through them both at the same time. So if we had a pointer here and a pointer here, or maybe should we iterate them one at a time? Actually, no, it can be fine. So this string is responsible for incrementing the index, and this string is responsible for decrementing the index, right? And what I mean is that if we were to create this array, right, let's say they're all default initialized to 0. Then for each of the characters in S, we would increment the index at the respective index. So 0 goes to 1, right? And so on. B will go to 1, and C will go to 1 as well. And the moment that we iterate through T as well, and considering that we're looping through them at the same time, this is responsible for decrementing the index. So decrement the index that C is respected or assigned to. So this will turn back to 0, B will turn back to 0, and A will turn back to 0. And essentially, if they're valid anagrams, then this whole array should equal to 0. So here, we can say SE array integer, size is a constant, 26. And then we can say size t I is equal to 0, I is less than size t and is equal to size less than length. And then plus plus I, and then we would say frequency array. We would convert the character into a zero-based index. So what is it? SII minus A, right? And then we can plus plus it from there. And then same thing, but we're gonna decrement it for t. And then, okay, so here, increment the characters for S, decrement the character for T, and then integram if the array is all zeros. Alright, so for int frequency array, we could say if num is not equal to 0, then we can return false, right? Else we return true. Okay, our solution was, where is it? Our solution used 107 megabytes. Let's see if that turns it down. Let's make sure it runs and works. Okay, that didn't work. Why not? Okay, if the lengths don't equal, have a frequency array, right? Plus plus a t of I, return false, else return true. Integram. What was case number 2? Does this default initialize to 0, or is it just random? Oh. Interesting. Okay. How does that work? So basically what that is saying, or the reason why that could not be working, is because this contains garbage values. So this solution only works based off the assumption that array starts off with all zeros. And the normal C++ arrays, they all default initialize to 0, right? So if you create an array something like this, right, this is default initialized to 0. But this isn't default to initialize to 0 unless you edit this. Why does this default initialize to 0? This doesn't. So this is called value initialization. This is the same thing as doing this. Oh, okay. Alright, so hopefully 94. I think it was 107. So that saved some type of memory. Okay. Here the solution. Is this my solution? Yeah, that is my solution. Let's ask chat if there's any more optimizations I can make. Given the solution for valid anagram, are there any modern C++ practices I can do to make the solution better? Okay, yes, we should be passing stuff by reference if it's a string or a large object, so we don't have to construct it twice or copy it over twice. Don't store n unless you need it. Did I not use it? Oh, that's true. It usually prefers direct use or range-based loops. Single loop with iterators. No. I'm actually not do that. Replace final loop with std all of. What is this? More expressive standard algorithm usage interview brownie points. Okay, the only reason so this looks like a lambda expression. Well, that's kind of cool. It kind of looks like TypeScripts or JavaScripts, like .map or .filter expressions. But what does this do? Does this use L lambda, essentially saying for each element and frequency, run this lambda for that element. Kind of like a JavaScript using a callback function for each of the elements. Do all elements of this range satisfy a condition? Oh. When was that introduced? Okay. When was std all introduced? It was introduced in C++11. Okay. So if we were to use that, it looks something like std. How did he use it? So this returns a boolean. Okay. So return std all of. We would pass in the iterator pointing to the beginning, which is .begin, .end, and then our lambda function. Any of this. Okay, so this is like an existential and this is like a universal. That's kind of cool. Okay. All of. Okay, so I guess what's cleaner, having it inline like this. Okay, and then ends x, right? So for each element, how do they style it? Styled it like this. Where it was return x is equal to 0. So this is saying for each of the elements for each x, basically you return if x is equal to 0, checking if x is equal to 0. This submit. It does. Very interesting. Okay. So all of introduced in C++11 accepts a lambda to execute per each element. Now I don't know why it's saying this, but I don't know. I feel like semantics wise it's probably easier to just loop through it and then return it, but I mean I guess it's preference. It's kind of cool to know. Yeah, so we're gonna mark that as the next one. I think it as well. That Alright, what is the next one? Next one is twosome. Alright, we're gonna knock these easies out the way really quick. I feel like for twosome, the idea here is to cover this over really quick. Twosome. These as well. So, okay, I feel like twosome is like the canonical or like the default first Leetcode question. So I won't really whiteboard this one, but basically we're given an array of numbers and we have to find a target, and we're supposed to return the indexes of each of these numbers, or the numbers that correspond to this target. Yeah, so for instance 3 plus 4 is equal to 7, and so we're supposed to return index 0 and 1. I believe there's only one valid answer that exists, so we don't have to worry about returning multiple indexes and so on. There could be negatives, and comes out length could be less than 1,000, or at least at most 1,000. So the idea here is to have an unordered map. That unordered map will map to it will map the number to the index. And the reason why we need to keep track of that is because if we're interested in finding two numbers, right, as long as we compute the difference from the number we're looking at minus the target, if we compute that difference and if that difference has already been traversed, we can just return the index of that difference. But without having to loop over through the array again to find the index of that difference, we could just store into a hash map, which will result in an O of 1 lookup time. So here I'm going to import unordered map and then constant alright, std unordered map and m maps number to index, and then for int I is equal to 0, I is less than nums dot size I plus plus, and current is going to be equal to nums I, and difference is going to be equal to current num minus target, right? If okay, can we use the, what was this called again? No, it was in this one. What was this called? What is this called in C++? Structured binding. Okay. Structured binding. So, can we use that here? const auto it insert, right, is equal to map dot insert or m dot insert. Actually no, because we're not checking if something has already been inserted, we're checking if the difference exists, else we would insert the current number we added. So if m dot find difference does not equal to m dot end, so this is saying if difference exists in map, right? So if it exists in the map, then we return index and then okay, alright, we return the index that we're currently at and then the index of the difference, else we're going to store the index of current num I. And then we can just have this in case there was no answer. Alright, hopefully I have this down. Oh my gosh. Oh, wait. Turn on at index I. Oh, okay. So we would store, what's happening here? We'd store 3 is mapped to 0, right? Is it because this should be flipped? Let's just grab this line, put it into here. Oh my gosh. Alright. If it does not equal to m dot end, then it exists. Current num is equal to I. Oh my gosh, the order matters in what we're returning. Okay. That's stupid. This should, hopefully, okay, nice. How does someone get 1 millisecond? Div, premap div, premap dot insert. Alright, yeah, that should be it for now. Alright, that is it for the code. The next we'll probably pick it up with either a project or by doing, what's the next one? By doing group anagrams, so the mediums. Alright, sounds good.